Welcome to the open source hardware track. I'm Patrick Bertolla. I'm working here at Neu in the digital team, and today I will be your moderator for the afternoon. Today we will have several talks in different topics, and we will have every talk will be 15 minutes long. We will have also time for questions. If in this 15 minutes, if you want to ask questions, go to the comment section below the video and ask there. I will get the questions and I will ask them in your stead, like we had this morning in the other session. There's also a portal called Sankt Virtual, where you can go afterwards to meet people and to talk with them about different topics. There will also be speaker and also moderator, which you can talk to. Today we start with a talk given by Nicole Ferber. She's CTO at Purism, and she has lots of experience with embedded devices. She will tell us how she created a smartphone, a completely free smartphone, using as much free technology as possible, and all the issues they had to tackle to be able to do that. We will have a lot of speakers today. Be prepared that with questions, we would like to have you that we have interactive talks so that you can have also discussion with our speakers. And as more questions you ask, the better it is for us, the better it is for you, the better it is for the community. So we just wait now for Nicole to connect, and then we start with the presentation. Nicole, can you hear me?
Yeah, yes, I can, and I'm connected, and video should be working. Oh, here we go. Excellent. Yeah, thank you very much for the kind introduction. Since we don't have that much time, let's get started pretty much right away. And just to put that straight, it's a whole team effort that we're doing there for creating this mobile phone. It's not just me. I'm just presenting here a lot of the effort that also the team has done. So what we're talking here in general is we wanted to create a free smartphone, and free as in freedom and not as in freebie or something like that. So this is similar to the freedoms that the Free Software Foundation defines for the free software, and that's also what we wanted to achieve with the hardware, so that you can use it as you wish for any purpose, that you can study it as much as possible, that you can change it, and that you can also share those changes freely, of course, with others. So that this was large part of the goal for creating this phone. So what you need to create a free smartphone or a smartphone in general is that you need a main CPU, which in the smartphones and embedded space is usually so-called system on chip, an SoC. So this is not just the main CPU, but it also integrates a lot of peripheral controllers for the different interfaces, for communication interfaces, and also of course controllers for cameras and the screen and things like that. And then, of course, you also need the wireless data interfaces like Wi-Fi and Bluetooth, and of course, last but not least, the cellular modem for 2G, 3G, 4G, and in some months also 5G communication. So that's a lot of parts that you need inside of that. What we also wanted to achieve to be as free as possible is that we want this whole thing to be as blob-free as possible, especially concerning the main CPU at runtime, so this main CPU I just described, because there are a lot more CPUs inside of that system running, for example, the modems and a lot of other parts. So don't want to have some mystery firmware blobs inside of that, and we also, of course, do not want any proprietary closed source drivers or closed source libraries inside the user space of the main CPU. So no blobs as much as possible. So especially for the radios like cellular, Wi-Fi, and Bluetooth, it's almost inevitable that they run some kind of firmware on the hardware. And we wanted to have this mostly separated out from the user space, from the main CPU. So the firmware for those cards is separated and sitting in hardware on those hardware modules. So on the modem card and on the Wi-Fi Bluetooth card. Everything else, especially everything running on the main CPU, is based completely on free software. And so the whole system, and that was the goal from the beginning, should be RYF ready. So this respects your freedom certification by the Free Software Foundation. And the whole design should be hackable for everyone. So we also will make are already doing this, make the schematics available for the whole thing without NDA, so that you can actually see how components are interconnected on the PCB, and that you can change the software accordingly, also on the very lower system level, hardware near level. So what we, in the end, came up with as a solution for achieving all of these goals is that we chose the NXP IMX8M Quad CPU as the main CPU. That's based on a quad-core ARM quad-core Cortex A53, each core up to 5 gigahertz. This SoC has enough peripheral interfaces to create a mobile phone. So it has the MIPI display controller interface and camera controller interface, SDIO that we use for the Wi-Fi to connect to the Wi-Fi card, USB 3 to connect to a PC, and a lot of other peripheral interfaces like SPI, I2C, and all these things. But most importantly, we chose the IMX8 for two reasons. One is the longevity of the availability of the CPU, because NXP is known for that the CPUs have a long lifetime. And very important thing was also that the integrated GPU, the graphics processing unit that does all the OpenGL 3D and user interface rendering, is this Vivante GC7000. And this was one of the first 3D GPUs that was fully supported with free drivers. By now, today, we also have pretty good development on the Mali side. So the Lima and Panfas drivers are pretty good, and the Adreno, free Adreno drivers become available for some of the Qualcomm platforms. But the the SoC that's best supported with free software currently still is the NXP IMX8M, or the successors or predecessors of that. So we chose this as the main host CPU. And then for the radio cards, this was a quite long quest to find some that had the firmware embedded on those cards. For the cellular modems and for the Wi-Fi cards, we in the end came up with that we indeed use separated cards in a smartphone, which is a quite unique approach. And one of the reasons for that was that we found that integrating especially the modem chips themselves directly onto the PCB is extremely complicated, because you don't get those chips just on their own. And that's not easy, especially when you're a kind of small company like we are. Even if we're looking at a quantity of 10K or something like that, then larger modem makers like Qualcomm, for example, they won't even talk to us for the integration support that is needed for that. So we took existing cards that you can find on the market. For the cellular, we chose an M.2 form factor 3042. And we offer currently 2 modem cards for the phone. One is based on the Gemalto PLS8 modem. The other one is a Broad Mobi modem, which is made in China. Fun fact at the side, both of them are based pretty much on the same Qualcomm chipset inside of those modules. And these modules also contain the firmware to run them. So in the end, on the other side, there's just the USB interface that we're using for all the communication, and that goes to the host side. For the Wi-Fi, we have a M.2 2230 card that's a little bit smaller form factor, connected via SDIO to the main CPU. And this was also quite a quest to find a M.2 card with Wi-Fi Bluetooth that has the firmware on the card, and where the host is not supposed to download the firmware at runtime to the card. We even had to pay some significant engineering fees to the company making this card. So finally, we have one, and we used SDIO there for power conserving. SDIO is less power hungry than, for example, USB in that case. In general, pretty much any M.2 card using the same interfaces that we're using there to communicate with those cards can be used inside of the device, which is also pretty cool, so that you can later on either upgrade the phone with a different cellular technology, or also use different other cards. For example, something like other ISM band communication, LoRa, or something that comes to mind if you want to just pull out the card and put in something different. So that's also pretty neat. So we had a long development effort also on the hardware side. We started off that we created a development kit so that we have something in hand that we can also start the software development pretty early on, and especially also enable application developers to help us with with porting free software to such a form factor of device, because since we haven't had this kind of hardware freely accessible in the free software communities, there's only very little actual software that can run on a mobile phone and a smartphone. So we wanted to have something very early on to help the software development effort, and that's the hardware design of the development kit that we released in December 2018. And that's the development kit, and you can already see the resemblance with a mobile phone. So we have the screen here on the left-hand side, which is a mobile phone screen, microphone on the bottom, speaker on the top. And on the picture on the right, you see the cellular modem on top, which is a different one than we use now in the phone. The Wi-Fi card here on the right-hand side, along with the camera. And that's a system on module here, including the CPU, the eMMC down there, and the RAM down there, and the PMIC here. And here, this development kit still even has the Ethernet, which is pretty cool for development. And later on, during the next year, we started the development of the real smartphone main board. And this is what you can see here. So that's the front side of the main board with the 2 M.2 slots here on opposite sides. In the center, there's the main CPU, the NXP IMX8. That's the eMMC. Here's the GNSS, vibration motor, and things like that. And that's the backside of it with these slots for the SIM card, and also the micro SD card. The RAM is here, and that's the PMIC here. Oh no, that's a USB hub actually down there. So that was quite a lot of work that we had to do there to get this integrated into this form factor. And just to give you an idea how complex this is, On this small PCB that you've just seen, there are over 160 different parts, and that's over 1,200 part placements on this single PCB. So that's a lot of parts that go onto this PCB. The PCB, I think by now we are even at 12 layers. So the one that you have seen was 10 layers. The smallest parts are 0201 for the ones familiar with the with SMT development. 0201 is a pretty small part size. The smallest ball pitch is 0.4 millimeters. So that's the size from one BGA ball to the next. So that's really, really super tiny. And the smallest diameter on the board is 0.254 millimeters. So everything is really super dense. And not that many hardware makers can actually, or SMT companies can actually do something like that. So that's pretty unique. And that's the end result. So this is what the current design looks like, the hardware design inside the case. The main board here is on the top half of that, and the lower half is pretty much completely filled with the battery for that. So it uses quite a lot of energy. And we have done quite good development on the user interface part. We're working with the GNOME communities there. Everything is GTK based and looking really super well by now. So what challenged us in this whole development? So first of all, suppliers for hardware. That's a huge undertaking to coordinate this with all those components, all the different parts to source these. And sometimes you have component lead times of up to 20 weeks of some components or even more. So just the logistics alone for getting this together is sometimes a nightmare. Then partially also getting proper developer information for all these hardwares is really challenging, because sometimes you only get product briefs or something like this, or really strange SDKs that don't work out. And even, I already mentioned this, even at a size of the project for 10K products or even more, we're still a pretty small fish in this sea, in this ocean of hardware makers and consumer electronic makers. So it's really hard to get with those hard chip makers into negotiation, how to get better documentation and support from them. And of course, also in the end, there's almost no way to get around China for making consumer electronics. So there's a lot of communication and back and forth also going on with the Chinese contract factories that we have contracted. Then another big challenge is, I already mentioned this briefly, more and more chips these days require firmware downloaded runtime through the host CPU and the host interface. In the earlier days, it was quite often possible to add an external storage to those chips, like an SPI flash, and have the chip download the firmware itself into itself, like a Wi-Fi card or a modem, something like that. But more and more complex chips require the host to download this firmware into the chips. And this is a big problem with the Respect Your Freedom certification, because this mandates pretty clearly that the host CPU must not touch any binary only firmware. And then, of course, for a mobile phone, which is an intentional radio emitter, all the regulations and certifications is a huge undertaking, especially we want to be able to supply this phone to worldwide regions everywhere. So all these different regulations and certifications are a major problem. And this costs a lot of work and a lot of money, I can also tell you, to get this right and to get this done. And then, of course, I also mentioned this briefly, due to the lack of hackable hardware in the free software community for quite some time for this mobile space, there's only also very little experience in the free software communities with this kind of device. And we also hope to be able to change this with the device that we are making there. So some few other lessons learned, and that's the last slide. Everything takes in this project, and probably also with a lot of other hardware projects, everything takes a little longer than expected and also gets more expensive than expected. Hardware is really hard. It's a tough business. What we also learned the hard way is that also hardware and chips have bugs, yes. And sometimes even the hardware makers themselves don't know about these bugs. Very interesting experiences you're making there. What we also learned is that everyone in the industry also struggles with brand new technologies. So one of the huge struggles that we currently still even have a little bit is, for example, USB Type-C. That's not super new anymore, but there are a lot of issues still in there. All this negotiation taking place for role switching and the different modes there, and power negotiation with up to 100 watts over this small connector and stuff like that. It's not so easy, and not everyone does it right out of the gate. So that's pretty interesting. And also the information that you get is, well, so and so. And what we also learned is that even the chip makers themselves sometimes don't know their own, because they have licensed parts of that from someone else and don't have the information. And that's also pretty interesting. But the good news is, what we also learned is that the free software and free software communities are not so alien anymore to hardware makers as it used to be. So more and more support can be get from those hardware makers and also chip makers, and they are more and more aware that free software needs to be supported on their hardware and with their hardware. So that's pretty good. So bottom line is, we're getting there. It takes a little longer. It's an interesting ride. Come join us. We want to empower the people so that we can hack the planet. Thank you very much.
Thank you, Nicole. Thank you, Nicole. We have multiple questions, but we don't have time. So I would propose if you could check the comment section of our track, maybe you can give some feedback to the questions we got.
Sure, absolutely.
Thank you, Nicole.
Thank you very much. Bye-bye.
Bye. speech, it will be given by Simon Dalvay. He's our young developer and a freelancer working in South Tyrol. He is created together with Neu, he created an infrastructure of e-ink displays, and he will show us today what he has done. Simon, you can start with your presentation.
Thank you, Patrick, for the introduction. So today I'm going to talk how to create Arduino e-ink room information that has automatic content. And I'm Simon Dalvay. I'm a freelance developer in South Tyrol, and I'm developing since school, more or less. And let's start. The idea was from the Neu Park, and the main idea was to digitalize any information board in the Neu Park. Like in the rooms you have, for example, in the office, you have the names and the room number of the people who are inside. Or also on elevators, you have all the companies that are on every floor. And we wanted to make all these information boards digital with e-ink displays to have low energy usage displays and don't have to change the physical information board every time information changed. And for that, we wanted to use the Arduino and of course e-ink displays to keep low energy. As you can see here in the image, this is the first prototype. Here you can see these are the e-ink displays. Here the Arduino with the e-paper shield to communicate, and it's connected to the computer. So at the first prototype, you could send this simple image to the Arduino. But we also wanted to have an API and a web app to control all these displays and automate them. So we used a Spring backend and a Vue.js frontend to create that. So here you can see the architecture of the project at the moment. So basically, it has the REST API written in Spring Boot that communicates with the Vue. Then over Hibernate, we have communication with Postgres. And then we have a Python proxy that, because the Spring Boot API will probably run, for example, on iOS. And so it can't directly communicate with the Arduinos that are on our local Wi-Fi network. So we had to use a Python proxy to make this bridge. Otherwise, we would have to install dynamic DNS to every single Arduino or just on a proxy, and that was much simpler. And then we used WebSockets, but I will explain that later. And the Arduinos, basically the displays you saw before, you can plug them in now at the moment. And over UDP, when you plug them in, the Arduino broadcasts its MAC address. And then the Python proxy reads this MAC address. So, this is a new MAC address, or I know this already, but he sends that to the Spring Boot API. The API sees, okay, it's a new display, let's send a new image. And then it goes all the way back, and the display arrives at the image arrives at the display. And so basically, you just have to plug it in, and it works. You don't have to configure anything on the displays. And the communication between the Python proxy and the Arduino itself is over normal Wi-Fi, over HTTP requests. And this is the web app I created. I have to say I'm a programmer, not a designer, so it looks not so well and not so good, but it does what it needs to do. And basically here you can see displays, because at the moment the API is also able to fetch events from today.neu.bz.it, where all events on the Neu Park are listed. And then it fetches the event, creates an image with the information of the event that's happening there, and then sending it automatically to the displays. And here you can see it's a simple list with details. I can send the image, clear, or ask the state. I can also invert the image, because at the moment the images are only black and white, because we just have displays with two colors. And by inverting it, for example, this would be white on black instead of black on white. And then you can create displays with a simple create or simpler, or the more complicated way where you can put the IP address and everything. and edit displays. So these are then the displays basically I created with my API. And here you can see an event for the seminar room 4. The organizer is Noi. Here the logo as always, the title of the event, and the time. And so by fetching the data every day, we could update the displays according to the event. And so we would not have to print it on paper and every time go there and change it or something like that. You just need to click, or you don't even click on the computer because it's automated. So this is a really cool project. And we will also talk about other use cases later. But as all good things, there are also problems. And one of the biggest problems at the moment is that images are not always shown correctly. And that's because basically the Arduino is not made for big data transfer. The Arduino is made for reading a sensor and maybe sending a flag, it happened or not to transfer full 200 kilobyte images. So this was a big challenge for me, but at the end, I basically created a 0-1 array with all the pixels of the image and sending that to the Arduino. And the Arduino then writes every single bit directly to the display. Because the Arduino also have just 2 kilobytes of RAM, so I could not even save the image before on the RAM and then render it on the display. I need to do it directly. And then, sorry, I didn't want to go to the next slide. Then we wanted to use WebSockets for the communication between proxy and the API. Because basically, at the beginning, we had the problem that the API had his own URL because it's running on OBS, so you have your within DNS your URL and you can use that. But our local proxy, we had to install something like local tunnel or so, giving us a URL. But that is not stable and it didn't work so well. So we talked about using WebSockets, because in WebSockets, once the communication is running, it's bidirectional and running all the time. So the proxy just needs to say to the API, I'm here, and then the communication runs. So we didn't need to set up a complicated proxy because it can communicate over WebSockets with the API. And it's not a problem, it's more a physical aspect of the displays itself, but ghosting can happen. Ghosting is if you leave an image on an e-ink display for more than, I think it depends on the display, but it's like 1 or 2 months, it could be that the image gets burnt in on the display. And then if you change the image, you will still see a small shade of the previous image. So what you have to do is just update the displays or clear the screen at least once a month or every some weeks. And you could do that because everything is automated also at 3 a.m. so nobody will notice it. But I wanted to mention it because it maybe could affect how you can use the displays. And other use cases, like I had the ideas, but there are a lot of ideas out there. We can talk about it later. It could be a menu of the restaurant at the entrance of the restaurant. Also elevator information board, I said before. Bus station plans, because also they change every month and when the school begins and so they just would have to click to change the station plans and add walls or whatever you can imagine. And the good thing is that the API is basically like an image portal for displays. So you could actually, with some coding, you have the ability to change the code, but attach every display you want. Because at the moment, the API gives you a monochrome array, but you can also disable that step, and it gives you simply the BMP image or the PNG image. So it could be used also with a television and everything you want. And next steps, we wanted to try LoRaWAN instead of Wi-Fi because LoRaWAN uses much less energy than Wi-Fi, but of course it's much slower, so sending images will be even more difficult, but we will try our best and see. Then of course attach a battery to see how long the displays could work autonomically without any power source. And then we also would like to have authentication for the display itself, that not everybody can just, by knowing the code, sending images to the displays, and better authentication for the web app, because at the moment it's a hard-coded user pass. Like it's not good at the moment. And of course, improve the web app and the UI and the UX, because at the moment it works, but it doesn't look good. And another cool idea would be attach a GMS module to really kind of place it wherever you want, like on a mountain or wherever. Like with a GMS module, a battery, if it works for 3 months, you could place it on a mountain on the top and write "Hello World" like to the people who go there. I don't know. Could be anything. Or like dynamic information at heuristic hotspots, or wherever you want to have also low energy usage. And here you can find the links to the source code. It's divided. Of course, the full project is open source and available on GitHub. I forgot to mention that. And basically here you can find the code for the API, here the code for the web app, and here the Arduino code. And the proxy code is included in the Spring REST API code. And so I want to thank you very much for the attention. And now, if you have any questions or can start a discussion, I also opened a table in Sankt Virtual. So if there is a big interest, we can also talk there later.
Thank you, Simon.
Welcome.
We do have questions, so maybe you can answer this already.
Nice.
Why do you use UDP and TCP between the Arduinos and the proxy?
I used UDP just because I didn't find another easy way to broadcast my MAC address. So basically with UDP, I had the possibility to broadcast the MAC address over the network freely and set up a UDP listener on the proxy. And we use TCP to send the images. But I also found now WebSocket libraries for Arduino, so it could be possible to use the WebSockets directly on the Arduino. And so the proxy would not even be necessary at all. But it's still under development, so we need to check it out.
Okay, and a question that comes from me. What does such an e-ink display, what's the cost and how long does it, how often do I need to change the batteries?
So at the moment, we never tried with batteries, but I think it will last about some months. And the cost of the displays are currently, I think you can find them online for around $30, $40. If you buy more, of course, they'll get always cheaper. And the Arduino for $20, and the software is for free. So I think with less than, for sure, $100, you will get an ink display. For saying a raw cost estimate.
Sounds cheap. Thank you, Simon.
Thank you.
Bye.
Bye.
So our next speaker is Abraham Mejia Aguilar. He's a senior researcher at URC European Academy of Bolzano, and today he will tell us about alpine safety through open source and open hardware. Abraham, the stage is yours.
Hi, thank you very much. Yeah, here Abraham here from URAC. I will introduce you a little bit of the results that we are until now getting in the project START. It's a collaboration between some Austrian partners for the mountain rescue operations, also some South Tyrolean partners here in the province of Bolzano, and some others from Belluno. So I will introduce a little bit the free and free software, free hardware that we are proposing, especially for the mountain rescue operations. Yeah, so we all love to visit mountains, of course. We are doing several activities in these mountains, like hiking, climbing, cycling, or skiing. However, we are in risk to suffer accidents or to have some potential problems due to the lack of experience, to the weather conditions, to the non-planned routes, or the effect of some other humans that reduce, for example, avalanches. So in this situation, we are participating in a project that is the START, that it means for the smartest for alpine rescue technology. Our participation in URAC is basically to provide develop IT applications that are accelerating the alpine rescue chain. So then one of our main objectives is to really validate and test this technology in a pilot area to really provide this advance or this development to the mountain rescue operators that are our stakeholders. So we identify inside of the province this geopark Wetterbach that is 40 minutes away from the city of Bolzano here in the province of South Tyrol. Basically, this place is really interesting in general for the people because it's an open museum. It provides a really, really good insight about what is the Dolomite, what is about the geology changes over millions and millions of years. And then, of course, it is the main attraction for several scientists, hikers, or in general family that want to spend some really nice time in the nature. So let's say the park is organized in a way that they have a really well-planned structure, divided in several walking paths, showing some interesting sightseeing or point of views. To get in touch to these changes in the geology. As you can see in this image, the visitors that are around 60,000 per year walk inside of this hostile or aggressive environment that is difficult for some people to really lose the perception of this environment or to easily get lost. Additionally, as you can see in this photo, this place is a natural canyon, let's say, and sometimes it happened that occurs some sudden storms in the top of the mountain, carrying a lot of water, producing floods, and of course, in consequence, bringing some material like rocks or trees. So the park itself has an internal regulation that to visit this area, it's mandatory to use the helmet. And in this way, we are proposing the use of a transceiver. Basically, the transceiver, if you have some experience in mountains, we are using a lot these transceivers to localize victims that are buried on their avalanches. So the main difficulty or the main problem of these standard transceivers is you can only reach up to 40 meters of distance. And it's, of course, designed to use in an open spaces, in this case, the mountains with the snow. So here we are really proposing to develop this technology in one of the most complex terrains, that is the canyon. Inside of the canyon, it's really difficult to receive any electromagnetic signal. So inside of the canyon of particularly Wetterbach, you have no signal connection for the telephones. The GPS is not working inside. For the normal or the standard procedures for the mountain rescue, you don't have clear visibility, for example, with the helicopter. So then you are summing up all these limitations that complicates the process of a rescue. So then the strategy that we are proposing here is the use of a transceiver. As I said, is basically one communication system that of course communicate with the other side. So, and then we are proposing to integrate a multi-radio frequency sensor that is implemented in the helmet. As I said, it's mandatory to use this helmet to access the park. Then the second stage is, as you are walking in predefined walking paths, we are proposing the installation of some stations. It's not a big infrastructure. There are like some devices that are more or less like 10 centimeters long, and then all this information collected either by the helmets itself or the stations is transmitted to a centralized station that is in this case the welcome tourist office in the park. Everything is, let's say, like a managed internally in one database, one data platform. And in case of emergency, it's possible to send an automatic flight with the drone that is equipped with the radio transmitter as well to localize the victim easily. And also to provide immediate location to the rescue teams. So it's more or less a collaborative system that accelerates the process of rescue. So we are in the current phase of developing this sensor. So we integrated currently let's say like at the board, we are using a PyCom system board, specifically exploiting the LoRa. That is meant this technology for long range transmission systems. Basically, you can reach up to 40 kilometers in an open spaces. In this case, we validated and tested the system and is reaching more than 500 meters. That is a really good advantage for these mountain operations. And also this board includes Bluetooth. Then Bluetooth, we are using this protocol with one of the beacons. This beacon technology, of course, is also like using or exploiting Bluetooth. And then we are providing this integrated or multi-frequency system inside of the helmet that is easily tracked by this station that I mentioned before, but also by the drone itself. So you can see right now, like the development that we are doing. We install the sensor in the helmet, so we are validating the prototype and also developing some experiments in the park. So let's say like in the phases, this is the base station that communicates permanently with in this case with the drone or with the helmet. And then basically the idea is that is based on the propagation of the signal and intensity of this signal that is collected by the electromagnetic wavelength of this transceiver. So the idea is like basically continuously following the intensity of this indicated by the RSSI, that it means for the received signal strength indicator. We localize where is more possible to find this victim. And then in coordination, in collaboration with the drone, provides automatically thermal imagery as well a normal photo. And then we can identify the victim that is in some part of the canyon located. At this moment, the drone sends to the automatic station or the automatic system the coordinate, and then this coordinate is easily retrieved by the mountain rescue teams. That minimizes the time that is necessary to localize this victim. So then, as I mentioned also, this information is transmitted in quasi-real time to a central station. These maps are like elaborated in a GeoNode platform. This GeoNode platform is an open source software. So we are at this moment developing the prototype phase that includes this information. Of course, every single helmet can handle a type of identifier that is really attractive, in particular to the IoT applications, because you can collect several information regarding, for example, which is the time that usually one person is visiting the park, the type of population that is visiting this park, of course, the routes that are more frequently walked. Then it's an additional tool for the park, of course, to get the maintenance of this geopark area. So we are analyzing now this integration in order also to provide the insight and also the collaboration with the park. So then basically right now we are validating the prototype as I mentioned. We are in the definition of creating this autonomous localization method using the drone and the sensor itself. And as a conclusions or preliminary conclusions, we are providing a new technology system to the specifically used or exploited by the mountain rescue teams. By extending at least like 5 times the range of localization of a victim, that this could be easily exported or transformed to the transceiver in avalanches. But this is also attractive, for example, to urban environments if some people is necessary to track, or if it's necessary to implement this type of localization systems, even not in a person. So of course, for us, it's more attractive to provide this technology for the mountain rescue operations because it's the project that we are working. So then, of course, as I mentioned, it's an attractive tool considering the software perspective because it's an added value generating automatically this game information, the link with the databases, and the rapid creation of interactive maps either provided by the drone for emergency situations or just for the management of the park itself. So from my side, this is my presentation. I really appreciate a lot the support that we are getting from for the Interact project that is funding this START project. Also, we appreciate a lot the support from the NOI Tech Park that is providing us the beacons to integrate this or to complement this LoRa transmission system using now Bluetooth. And of course, we appreciate a lot the support from the park and the mountain rescue teams, additional with the NOI Park. So now there are like 3 minutes for questions. So I'm here to answer any eventual doubt or question. Thank you very much.
Thank you, Abraham. We have questions for you. The first question is, do you perform on the device computing like edge computing for computer vision tasks?
So the vision computing is executed directly on this platform, this management system platform. Currently, we are in the development of the algorithm to really localize or to find the exact position. Because if you consider that the image that you receive from the drone is basically a photo, you have to transform immediately this information into coordinates that basically depends on the elevation that the drone is flying and the center position of the drone. So this is a parallel process that is on an additional system.
Thanks. Another question: how do you feel with the situation? How do you deal with a situation when there is no signal? Do you use a SLAM approach? If yes, then how do you deal with computation issue that may arise with resource-constrained nature?
Sorry, I didn't understand really well. The loss of communication, or
if there's no signal, do you use
signal in the drone or signal in the sensor, or so? Because basically the system itself provides signal to, so it's radiating permanently the helmet. It's permanently radiating these signals, these frequencies. And then the other part, the receiver, is getting this information itself, or the information that the helmet is providing. Then by triangulation processes, like the normal standard, like the ones used in the GPS, the antennas or these stations that are positioned on the park can estimate a little bit the position of this helmet. So basically, if there are no signal, it means like the system is not working. But for the perspective of the drone, if there are no specific signal, basically we have the possibility to control everything in manual mode for the flights.
Okay, I think you can also maybe ask or talk to the guy in the comment section below, so you can clear up misunderstandings. We have one more question for you. Do you only need a drone and a sending helmet during an emergency? Why do we then need to install a tracking network station?
So let's say like the drone is just an added value. So the ground stations that is consisted on the antennas is the most important one. So the drone itself is only used for the emergency and the case that some people is lost or if it's in some potential danger. So then we can first track the activities of this person with this ground sensor network. And then in case of some emergency happen, then we send the drone to localize this victim.
Okay, thank you, Abraham. I think it was a nice talk. If you still can give some feedback in the comment section, would be nice.
Okay, perfect.
Bye.
Bye, thank you very much.
So our next speaker is Gabriele Scarton. He's a young developer working at Gruppo Force Bolzano. He'll tell us about Blue Lemon. It's an automatic system to monitor landslide surfaces through beacons and drones. Gabriele, can you show us what Blue Lemon is about?
Yes. Thank you for the presentation. Now I will present how we use beacon in the Blue Lemon project. First of all, the Blue Lemon project is a proposed solution for gravity-driven natural hazards as landslide and avalanche. They pose an important threat in alpine areas. They are a safety risk for humans, they can damage structure, and they also have an impact on tourism. Our solution is an innovative monitoring system working in alpine conditions, which integrates state-of-the-art technology, IoT Bluetooth beacon, and remote piloted aircraft system. The development of the project is co-founded by Provincial Fund as Cooperation Project number 6 of 2008. As cooperation project, we have a partner and supporter. The lead partner is a group of us with over 20 years of experience in ICT. It's where I work, and we are collaborating with several research centers around Italy and Europe. Then we have Mavtech, which is the technology partner for the drone part, which is also be the next speaker at this track, and we'll speak about the drone part of the project. Then we have URAC Research, the research partner for data analysis. We have also some supporter, the two division of Noi Tech Park, the Beacon Sud Tirol Alto Adige project, which provide us the beacon, and the Provincia Autonoma di Bolzano Alto Adige. So, how does the Blue Lemon project works? First of all, the researcher select a CITO where we deploy all beacon in one time. This is the most dangerous part because we have to be in the dangerous area. Then we scan beacon using drone, so the pilot could be near the dangerous area but not in it. Then, thanks to the drone, we collect the data and we make analysis. So this is not a real-time alert system. We place the beacon, we scan, we collect the data, and then we analyze the data. We leave the beacon in the area, and at some interval, we can repeat the scan how many times we want. And then when the project is done or we have enough data, we can retrieve the beacon. For this project, so we need a particular beacon because the alpine environment has extreme weather condition, is a very large area, and also is a beautiful area, so we need to preserve it. So we need a beacon which is wireless. We cannot rely on cable in extreme condition. The beacon must have a small cost and a high availability, so we can map the whole area. And also, it must have a low impact on the environment and an easy configuration, so when the project is done, we can reuse them to other projects. Our test beacon are provided by Beacon Sud Tirol Alto Adige. They are Contact IO Bluetooth Low Energy beacon, which are with 7-year battery that are replaceable. They are small, so they are easily adaptable to various supports, and they are extremely configurable via REST API. We decided to use them without pairing because REST API require a connection, and on Alpine environment, this is not guaranteed. We will use a lot of them, so we have limits on simultaneous pairing on Bluetooth. And also, we need the RSSI, which we could get using advertising packet, so pairing is not needed.
For a moment, we can't see your slides right now.
Sorry?
We can't see your slides.
Oh.
Your presentation.
Now you see the slide?
Now we see them, yeah. You have to go back to Jitsi and enable camera and then go back to the slides.
Okay, so I will start fast. So these are the partners of the project. I already described. This is how the project work. We place the beacon on risk area, then the pilot in a safe position, control the drone to scan them, and then we put the data in a computer to analyze it. This is the beacon we need. So wireless, small cost, and low impact and easy configuration. This is the beacon we use for test. It's provided by Beacon South Tyrol Alto Adige. It's a Bluetooth low energy contact IO beacon. And the important thing, and we use no pairing because the REST API could not work offline. There is a limit on simultaneous pairing, and the advertising packet gives RSSI. That is what we need. Then we can talk about the controller. The controller will be a companion computer installed on the drone. It will be a Linux-based system. So for the test, we use a Raspberry Pi Zero W. For the software, we rely on Bluetooth, which is the official Linux Bluetooth protocol stack. It's written in C, and it has no API specific for scripting. If you want to use them, you have to dig in the code and find the right function. But it provides interfaces for command line such HCI tool and HCI dump, which are used to scan pairing with beacon and also control the Bluetooth packet. During our preliminary analysis, we found out the Adafruit BLEIO library, which use a Python script to handling the interfaces of Bluetooth to get the data. We look at the code, which is MIT licensed, and we came up with our idea and our code. The beacon are placed not paired, so they are advertising. That we put in the drone companion computer a Python script with two simultaneous processes. XCI tool scan, which scan for Bluetooth low energy beacon advertising, and ACI dump row, which read the raw packet of the scan and extract for us address and RSSI. Our first tests are made at the Neutech Park building in the Gruppo FOSS office. We connected the Raspberry and a test beacon, and also we mapped some beacon of the Beacon South Tyrol project, which are installed on the roof of the corridors of Neutech Park. Since Bluetooth use frequency hopping for communication, the connection is not guaranteed. But we found all the beacon every time, and most of the time below 3 seconds. So this is the time set for every scan in the drone and in the Raspberry. Then we research for some algorithm to improve position estimation, but we didn't find anything that could apply to our innovative solution, because most of the papers are based on small scale system where beacon can be paired and give more information, and also are based on smart home, where the scanner is a smartphone, so they can rely on supporting sensor as Wi-Fi and accelerometer. Also, since smart home is an indoor system, the algorithms are based on indoor obstacle as wall that we don't have. And the most important thing is that they assume that the beacon are in fixed position and they try to estimate the position of the scanner. we took all this information to make an innovative solution. We decide a predetermined drone path, and with the GPS RTK installed on drone, we could know where the drone is, make him fly around the beacon, and make some scan. Since it's an outdoor system, the algorithm can be based on the RSSI value and on the comparison to previous scan and expected value. Due to COVID situation, we didn't do so many field tests. So our next step is to do as many field tests as possible to get all the data and check if our algorithm work on field, and also integrating with the drone GPS, and in order to improve the location data, pair with a low-range wireless network as RFID. Then we, as improvement, we could also handle pairing. So we pair only to the nearest beacon when we fly around one beacon. And also we can use this data in real time to control the drone path. My presentation is ended. I'm ready for question, and I will remind you that the next presentation will be about the drone part of the Blue Lemon project. Also, we can answer more questions in a prepared room in Casa della Cultura at San Virtuale.
Thank you, Gabriele. We do have some questions. First question.
Okay.
How would your system react assuming the beacons are not in fixed positions? Have you evaluated it already or plan to evaluate?
Sorry, I don't understand the question.
How would your system react assuming that beacons are not in fixed positions? Have you evaluated it already or plan to evaluate it?
Yes, beacons are not in fixed position, but we assume that the movement is very low. So we assume that the beacon will be very near to the previous position. So the predetermined path will be assuming that the beacon is in the previous position. Then we make the scan, and the difference between the previous scan and the actual scan, which tell how much the beacon is moved.
Okay, thanks. Another question. What are the challenges you're expecting when doing the field test?
What are they?
The challenges.
Okay. A challenge could be the snow. Because it's an alpine environment, we have to test how the snow will affect the communication. And also it will be a very large area, so we will have to optimize the code to use as less resources as possible to give most of the resources to the drone, which have a limited battery. Also, the drone has a minimum height for fly, so we will have to be as near as possible to use low-range wireless network and make a reliable connection to get the data.
So, and we still have time for one last question, I think. Why not use algorithms like Kalman filter to handle mobility?
Sorry, I don't understand the question.
Why not use algorithms like Kalman filter to handle mobility?
Okay. Yeah, yes, we analyze that, and we will try. We are preparing some algorithm, and when we could when we could make a field test, we will try some of them. At the moment, we are only preparing the code indoor, but without data, we cannot know how what will be the best. So we are trying some algorithm. When we will go out and test it, we will have more answer.
Well, thank you, Gabriele, for your presentation.
Thank you.
See you. Bye. Our next speaker is Alex Boyeri. He's a junior technical specialist at Mavtech. He will show us how the project Blues Lemon intends to go beyond current autonomous navigation capabilities of drones. Maybe, Alex, you can show us more about it.
Yeah, thank you, Patrick. So I'll share my screen. Okay. You should see me too.
Perfect.
Okay, here we are. So thank you once more, and hi everyone. I'm Alex Boieri, and from Maptech, and today I'm going to present you our research in the Blue Lemon project regarding autonomous UAV, the development of autonomous UAV for landslide monitoring in alpine environment. So, as Gabriele previously introduced, the Blue Lemon project aims to develop a low-cost automatic system for the monitoring of landslide surface displacement through the integration of both Bluetooth beacon devices, localization devices presented by Gabriele, and unmanned aerial systems, commonly known as drones. So the project aims to build upon innovative technologies and integrates these two technologies to create an innovative natural hazard complete monitoring systems for diverse environmental conditions. So it enables field information collection in order to support, for example, provincial services by providing accurate field measurements in the landslide displacements. The Blue Lemon partners are Group of Host, the lead partner, EURAC Research, so the Institute of EURAC Research, and Maptech is the technology partner. Maptech is a spin-off company of Politecnico Torino. Actually is currently located in Neutech Park as a technology company. The main focus of Maptech is the prototyping and production and development of remotely piloted aircraft systems, so drones, by transferring new aerospace technologies from research field to industrial and, for example, operational sector. The project, as I introduced before, tends to study and design a system to detect, in particular, and avoid the obstacles. So we developed the systems, and we are studying a system to detect and avoid obstacles during the navigation of the drone. This system obviously should respect the project requirements, for example, three-dimensional navigation or outdoor application, of course. So today I'm going to present you what we did. So we implement, simulate, and optimize a collision avoidance system through the use of an open source algorithm. We will see this later. And yes, so we at the end of this study we will evaluate the functionalities of the system also in a real-world application with real-world automatic or semi-automatic flight missions. The experimental setup we considered is composed by the guide navigation and control systems, and in particular by the autopilot, which is a PIXOC 4 with PIX4 open source firmware, laser altimeter, radio controller, and RC receiver, GPS with RTK capabilities, a depth camera to reconstruct the environment in front of the drone, and a companion computer to elaborate and to compute all this kind of information coming from the depth camera and to send the correction to the drone trajectory during the navigation. We considered in our study mainly three different scenarios. The first one is a simple scenario with no obstacles. The second one is similar to the Corvara landslide environment. We choose Corvara because it's the test site. We will use them in the real-world flights. And the third test we did is a test in a rough environment, a simulation of a rough environment to evaluate the functionalities of the algorithm at its maximum performances. So we evaluate the variation of the algorithm performances of the 3D VFH plus algorithm, obviously as a function of the different simulation parameters. The optimization of these parameters are done through the use of free robotic operating system ROS and gazebo visualization. The first scenario, the simplest one, we tried to perform a simple mission through waypoints with the first difficulty in the presence of a near hill. The collision avoidance algorithm, we saw that continuously recalculate the optimal path to reach every of these waypoints predefined waypoints, respecting obviously the flight mission and the collision avoidance parameter we set before. At the end, the vehicle is able to detect all these risky terrain variation as obstacles, avoid them, and continue his mission. The second scenario is a real monitoring flight mission simulation, obviously. And the drone is positioned on the ground control open source mission planner at the Corvara landslide coordinates. So it's used to simulate the presence of the drone on the landslide at the altitude of 5 meters. In this case, we didn't perform automatically the takeoff and the land mission with the collision avoidance system, but we only evaluate the performances during the navigation. So at the end, the UAV moves around by avoiding all these obstacles until it reaches all the target waypoints previously defined. So it's a good result. The third simulation is used to enhance the performances and evaluate the maximum performances of the collision avoidance algorithm. It's obviously with the standard parameter, the mission cannot be completed. Therefore, we try to optimize further these parameters, these simulation parameters, and we also slightly move some waypoints slightly further away from the rocks to let the drone reach all the waypoints. So at the end, the result is that the UAV once more reaches all the waypoints, and in this case, making trajectory with minimum distance radius from the desired path. That means that the drone followed the predefined mission correctly, and in case of the presence of an obstacle, it will avoid it and continue his mission normally. So here you can see a short video example of our simulation taken from Gazebo. There are two kind of parameters we consider: the standard parameters, that are the parameters maintained constant for all the simulations, that represent the weights, for example, dimension of the UAV or the optimal resolution. And on the other side, we have the simulation parameters, which are initially set up, and then during the simulation and the optimization process, they are varied to let the system be specific for the study application, for the task we want to apply. So at the end, we understood that the detection avoidance method we are considering is able to maintain the safety distance to the obstacles, in this case from trees, for example. And it continuously redefines the optimal path when all these obstacles are detected. On the other side, in case there are no obstacles in the trajectory, the drone will continue his mission normally. We perform a lot of other tests to verify also the random behavior of the drone with optimal route calculation, and also not to lead to negative factors. The optimization of these parameters, these simulation parameters, increases a lot the system performances and let us to have a good result at the end. In the future, we want for sure to expand the algorithm operation to all the mission phases. That means also to the takeoff and landing phases, which enable us to have a complete system with fully automatic, autonomous navigation capabilities. And in addition, we want to evaluate also, also the use of several sensors or hybrid solutions to ensure a higher vehicle field of view for the obstacle detection to enhance more the capabilities of the collision avoidance algorithm. This will be done to improve, obviously, reliability, accuracy, and sensibility of the collision avoidance systems in order to let us perform at the end a real-world flight mission to test the complete system in a real-world environment. In this case, as I previously mentioned, on the Corvara landslide site. So thank you for your attention, and if you have some questions, I'll be happy to answer. Otherwise, as Gabriele previously announced, we can find in the San Virtuale room to have a chat with you if you're interested. So thank you.
Thank you, Alex. We do have some questions for you. What do you do with remotely driven drones? If you, for example, enter a valley like Blätterparkschlucht, where you do not have a connection anymore, does the drone act autonomously? Do you have such AI implementation?
Okay, so the drone, in real world, the drone moves with GPS. When he moves autonomously, he moves with GPS information. So if the GPS information is still there, the navigation capabilities and the autonomously drone will navigate without any kind of issues. In case of no GPS signal, it will be troubling because we actually at the moment we don't have other kind of localization systems to enable the drone to let him know where he is actually at the moment. He will see probably the obstacles while he will not know where he is actually at the moment on the world. So this is troubling, yes.
One more questions. I see that you've used Octamap, and I assume that you have used occupancy grid-based approach. How efficient was it? Based on what I know, it's not that efficient when maps grow larger.
Okay, yeah, maybe we can have a chat more deeper later in the San Virtuale room where we can talk about our results, because I didn't insert numerical results in my presentation, but we have all this information if you want to know. And yes, actually, it's not the most maybe the most efficient one, but it's the one we found open to use and to adapt in our tasks, and so we applied it directly. So it's useful, it performs well, but yeah, maybe it's not the best at all, but for our purposes, it performed well.
Thanks. We do still have questions. Is the computer inside the drone strong enough to do complex AI decisions, or do you always need to communicate with a strong server located in the headquarters?
Okay, yeah, actually we are trying different solutions in this direction to understand which kind of companion computer on board is efficient enough to perform this kind of computation, because as you correctly mentioned, these are vision and vision computation are always troubling for a computer. So actually at the moment we are considering different solutions, starting from Raspberry to NVIDIA and other kind of companion computers, to understand which is the best compromise between costs and performances, and also weight, because for us is very, very important, the weight, because we have to minimize both the cost and the weight to ensure efficient end runs.
Nice. One thing that I wanted to ask, did you already do some test flights? Do you also have some feedback already?
With the collision avoidance, you mean? Actually, we did not. We are, firstly, as I mentioned at the end, we want to be sure that the system is reliable and accurate enough in the simulation before, in maybe also hardware in the loop simulation, where we are quite in the real situations. But real flights with this collision avoidance system, we didn't perform yet.
Oh, okay, then let's hope it will be soon.
Yeah, for sure.
Bye.
Bye, thank you.
See you. So our next speaker, we already had him here. It's Simon Dalva. He's a web developer, but as it seems, he's also doing a lot of game development. And today he'll show us how he uses Godot to develop his own game. Simon, show us what you've done.
Good evening, everybody. So now I'm going to show you how to create open source games with Godot. And my game studio is called Radical Pixels, but I'm working alone in my free time since 2 years now. And I started with libgdx. That is a Java library, also open source. And there you can code games for desktop, mobile, and everything, but purely in Java. And then in February, I already knew Godot because I once saw it on the FOSDEM in Brussels. And in February, I started using it, and I liked it a lot because you have your own editor, and it's much better than pure Java. So now I'm going to tell you what is Godot. So Godot is a program. You can download it on your browser. It's about 30 megabytes big, and it runs on Linux, Windows, and Mac OS. And you don't need to install any additional software to make games. You just need to download these 30 megabytes, can run it, and start coding right ahead. It's open source and completely free to use. So you can read the code, contribute, and also all the profit you make with your games, you don't have to share with anybody. Because, for example, on Unity or other popular game engines, you have to pay a fee when you're earning a margin or something like that. And it's under the MIT license, so it's completely free and open source. And it was released February 2014, So it's still quite young because it's only 6 years old. And for example, Unity was released 2005. So we have still a bright future for Godot. I think it's developing every day and getting better every day. And the good thing about Godot is that you can export it for desktop, so it runs on Linux, macOS, Windows, on also mobile devices, Android, iOS, and also in the web. But the web is a bit limited. You can't like render big 3D games in web. Like it's for really simple games. And the alternatives are, like I mentioned before, like the biggest market player, especially in mobile games, is Unity. Then libgdx, it's a bit old and it's pure Java, but it was my teacher kind of. So, and other like Unreal Engine, where you can make real like 3D good-looking games, like AAA games. And Game Builder is like a game engine where you can, without coding, just by clicking. And I'm going to tell you why to use Godot. Godot has a special way to do things. It works with scenes and nodes. And so like a scene could be everything you see on the screen. And you could imagine it like a film scene where you have a camera, and in Godot you really have a camera that sees the scene, just a part of the scene. You could also have an actor outside. And all the actors in the game are nodes. For example, in Super Mario, Mario will be a node, and all the pipes will be nodes. And the scene will be the whole scene, and every element is a node. And so we have types of like physics bodies to make collisions, or like a car or something like that. Then nodes could also be UI elements, like a label or a button or whatever. And then there are also general nodes, for example, for sound or for animations. I will show you later. Like the animation player is a big super node. And also like pathfinding nodes that are really useful for games, because many times you need to find the best path, and Godot already brings you just a drag and drop solution for that. And a good thing about Godot is it divides logic from the code with the visual elements. So the coder and the designer can work independently and will never interact, because Godot works over signals, so you can connect the UI with the code. And the designer can have his Godot running and run the game and make changes, run the game and see the changes, and the developer. But they never interact. Because, for example, in libgdx, it would be impossible that the designer does something without coding, because you have to code everything. And Godot uses GDScript. It's an easy scripting language like Python, and I prefer to use that. It supports also many other languages like C#, and there are a lot of bridges also for Go, Rust, like, because it's open source, there are a lot of plugins. Like, you just need to search on the web. It's amazing. And Godot has also big communities like groups on Facebook, itch.io, Discord, and there's also a lot of Godot, like the official Godot forums, where you can also make questions or answer. And there's also a lot of stuff going on Stack Overflow, like every programming language. And another good thing I wanted to mention is that with Godot, you can could run your multiplayer server with GDScript. So you don't have to learn an additional language just for the multiplayer server. And so with GDScript, it's quite easy. I tried it. Then it's hard to make multiplayer games, but the setup is easy. Like, it's always hard to make multiplayer games because of ping and everything. And for this presentation today, I created a small game. Basically, if you go to this link, you can play it online. It's the first time I exported a game in HTML, and it works straight away. Like, I like that a lot. And if you go to this link, you can play it also right now in the browser. And basically, you are the tax, and you need to press spacebar to jump. And there are Godot boxes coming, and you need to jump over the boxes. And now I'm going to show you how I created this game. It's kind of the game you can find in Chrome if you don't have internet connection and you have the dinosaur jumping over the cactuses. So this is if you open Godot. Like, now this is when the project was already finished, but When you open it, you can see here above. I hope you can see my mouse. Here's 2D editor, then you have 3D editor, script, and the asset lib where you can find demos and other assets for Godot. And now I'm in the 2 editor. As you can see, this is the scene, and the red square is like the camera I said before. So in the screen, you can just see that. Everything above you can see. And then the tags, like this is the scene tree. Here you can see all the actors, like the background, and the tags is a rigid body, a physics body. Here you can see the collision shape. Then here I have a 2D area, like this is, if the box comes, passes here, and touches this area, I increase the score. So I know a score happened. Then here you see the UI elements, and the animation player, and the timer for the boxes that are coming. And now I change to the script editor of the tags, because basically the tags is itself a scene. So we can think everything is a scene, like the scene itself, then the tags could be a scene where we can modify just the tags. Here in the tags tree, you can see I have a sprite, a collision shape, and a detector to check when a collision happens. And here you see a bit of code. This is GDScript. So basically, it's really similar to Python. You don't have brackets. You can use JSON like in Python, the dictionary, and it's really nice. And here you can also see the signals I mentioned before. For example, here you have the signal game over. And here in the body detector, if a body enters in this zone, this code gets played. And then I check if the body that is coming in is part of the group box, is a box. Then I emit the signal game over. And so the designer could say, okay, now it's game over. Like he don't need to watch the code. He just sees the tags can give the signal game over. And he connects that game over to an animation or something like that. So this is how designers and developers could work together. So now this is the tag scene in his 2D Wii, basically. And here I opened the animated sprite. Like if you open the game, you will see that the tax is walking and moving his feet. And this happens really simple. You just need to get the online every single picture, every single frame of the animation, put it in here, and then you can make walk animation, and it plays automatically this animation in the scene. And I'm going to show you how the animation player works. So basically here, this is the animation player, and this is cool because you can change every attribute you can see here over time. Yeah, you can change every attribute here over time. For example, here I wanted to make that the game when you start fades in from a blue screen to the game, so it's more pleasure to see it. And so I start with, here you can see the full visibility, and then I slowly fade out to transparent, and you will see that in the game. And I do that just by clicking here on full visibility. Then here again, I set on transparent, set the key, and I set the time, and that's it. Like in 20 seconds, you made a fading animation. It's really cool. And then when you start the game, like we'll press here, I enabled also visible collision. So you can see during the animation, during the playing of the game, the collision shapes of the actors. So you can debug easier the game. And here you can see the tags, like now this box, because I can't play, it's the image, that doesn't move. But the box would move here, and by pressing spacebar, the tags jumps over. If the box passes this, the score increases, otherwise you lose. And it saves you a high score, and that's it. So this was my presentation. I hope you enjoyed it, and I showed you a bit how to create games. Now, if you have any questions, I'm happy to answer them. Sorry, I can't hear you. I can't hear you, but I can read the question. Or I might just answer the question. I have to say I never really used pathfinding. I just wanted to mention it because it's really used in a lot of games. For groups. I think this will be solvable in Godot because it has its nodes, and I think somehow like it finds the path around the obstacles or something like that. So I think it should work on Godot.
Simon, can you hear me now?
Yeah, now I can hear you.
Okay, we are back. Little technical issue. So I will ask the question again. Would it be possible to use Godot in a non-gaming environment, like for instance, for simulation of scientific fields?
Sorry, can you ask the question again?
Would it be possible to use Godot in a non-gaming environment, like for instance, for a simulation or a scientific field?
Yes, for sure, because like you can animate, it's a 3D and 2D physics simulation. I have to say that the physics simulation by itself in Godot is not so good. Like other game engines have much better simulations. Like the collisions are not so good, but you could use it also to make apps, like for everything actually. It's also Godot itself. It's made by Godot, like in GDScript. So also the tool itself is made by Godot.
Okay, thanks. Let's go to the next question. We still have time for one question.
Okay.
Godot is open source. Have you had the chance to contribute to it? How is the community?
Yes, I had the chance to contribute to an ad mob module, because like in mobile games you can show ads of Google, and there was no ad mob module for iOS running, and with a programmer from Brazil, we got together and made this module. Like you could find it on Point Studios on GitHub. It's really nice.
Okay, thank you, Simon. This was the time, but really nice presentation. Thank you. See you.
Thank you. See you.
Welcome back. Our next speaker is Stefano Dondini. He's a senior researcher at the European Academy in Bolzano, more precisely at the Center of Sensing Solution. He'll give us a presentation on how using IoT monitoring of our microclimate can improve life quality in our urban communities. Maybe, Stefano, you can give us a good overview about it.
Yeah, I hope so. Do you hear me?
We see you.
And do you hear me?
Perfect.
Okay, perfect. Really good. So can I start?
You can start.
Thanks a lot. So I'm Stefano Tondini, Eurorack Research. I'm going to talk about low-cost high-resolution global navigation satellite systems that have been put in place for microclimatic monitoring by means of the open source suite RTK-lib. The outline of my talk is going to touch really briefly the state of art for GNSS application, and then we'll go through the issue why it's so crucial to have mobile microclimatic monitoring. I will then touch a bit of the theory of real-time kinematics, post-processing, and the features of RTK-lib. Then I will show you the prototype we accomplished based on Raspberry and the low-cost hardware. I will show you how the application we put in place looks like. And then I will go through some filed tests that, however, they are still preliminary. As you know, this year we didn't have room to go too much in the field to do tests. So when it comes to the state of art for the GNSS application, we do see they are most likely pointing toward machine control, logistics, moving things around, and try to get the best positioning also when it comes to buildings, infrastructure, construction, and whatever. However, we don't see anything about microclimatic monitoring right now. This is because there is not too much business still open for such application. It's much more research up to now. However, it's really, really crucial to go for microclimatic monitoring. And let me take as an example what they are doing for a couple of years in Cambridge. Actually, here the MIT is publishing environmental data that they are acquired by moving rovers that are actually the means and the trucks for the garbage collection all around the city of Cambridge. And in this way, they have been able, by means of really few urban vehicles, to monitoring all the environmental phenomena, or the most important environmental phenomena that are actually occurring there. And they have so really high resolution time series in different positions all around the city. And this is actually so interesting when it comes to the environmental phenomena monitoring. But it could be even much more interesting and have so big outreach when it comes to the coupling of this mobile microclimatic monitoring with modeling and simulation that nowadays, due to high performance computing, can be carried out at district scale. And whether we encompass within this simulation both the data from moving rovers and some further external data, we can build up what we call the context, that, by the way, is going to be much more clear in the presentation that I will give in half an hour. By means of building up the context information, then we will be able to provide the citizens as well as policy and decision maker by added value information and, for instance, enhance the well-being for the citizens, as well as to give support to adaptation and mitigation strategies that should be put in place in order to cope with the current climate change. So now let me just give you some hints about real-time kinematic processing. That is actually a procedure that is used in order to accomplish a more precise positioning when it comes to moving GNSS antennas. So, of course, all of you knows how does a GNSS work. It basically gets the signal from the satellite constellation that are covering all the sky view. And yeah, we can have something that is acting as a base station when it's steady, and it is averaging its own position over the time. So that is going to be more and more and more precise. But when it comes to moving things, if they are considered standalone, they can reach only the meter level precision. At seconds means that they are moving. In fact, depends also on the speed they are moving to. However, when we couple, for instance, two GNSS devices and we perform a little bit of computation about phases and the coding of the carrier phase that is coming from the GNSS satellites, then it will be possible to achieve centimeter precision instead of meter precision. And actually, this is really, really crucial when it comes to microclimatic monitoring, because the spatial enriched data are needs for sure to be really accurate in order to be significant for the simulation that I was addressing before. However, how to carry out all this, because could be that we end up with some device of one brand, some other device for another brand, and then all this calculation, where to run this processing, we do have the chance to go for an open source suite called RTK-lib that is encompassing 7 modules. You see that they allow you to do many different things, from plotting the results of a single acquisition and all the satellites of the sky view or the constellation, converting also the things that they are coming from, the data that they are coming from different devices, because could be that they do have a proprietary format, and then they should be turned into the proper format to be post-processing. We can also do some tracking of paths when the things are moving, and so on and so forth. So let me now show you what we did in the lab. Actually, these are the building blocks of the prototype that we developed, and in the movie here on the top, you can see that it has been embedded into an IP67 box, this white one. And you see, mainly it's based on a Raspberry, that is the core unit, that beside the coupling with the GNSS chip and the GNSS antenna, it also reads out the sensor, and it is running RTK-lib in order to output directly formatted data in order to ease then the post-process, and of course also encompasses GSM connectivity by means of this LTE module. How does the application look like from the point of view of the architecture? Of course, as I was mentioning before, we are using a base rover configuration, where the base actually is given by the servizio geodetico of the province of Bolzano, and the rover, like you saw in the previous view graph, is just a moving device with that prototype that we put in place. They should see the same constellation, of course, to achieve RTK, and they are providing to the environmental data platform the data that are formatted into RENEX format, that these data are, of course, kept within a virtual machine that we dedicated to this application. And upon this data, we can perform RTK-lib processing in order to achieve, in fact, real-time kinematic correction, so that we will be able to achieve the centimeter positioning accuracy even with this low-cost solution. And this position-enriched sensor data can then be exposed via WebGIS or the GeoJSON data structure. Okay, let me go really fastly to the preliminary test that we did and preliminary results. We actually are going to see 3 main tests. The first one is encompassing only one rover that one prototype that has been kept in static mode, and it has been placed just upon this tripod that is structured to keep it as steady as possible. And I was not cheating before when I told you that by means of RTK, we have been able to pass from the meter accuracy to the centimeter accuracy, because when we encompass the RTK post-processing on the static acquisition of this device, the RTK has been carried out by means of the data from the base station of the province of Bolzano, then we have been able to achieve the centimeter accuracy. Then the other 2 tests that are even more interesting, and I'm going to show you briefly now, they've been carried out by means of this e-bike, where the prototype has been put here, and the antenna on this pole, in order not to be disturbed by the bike driver. Okay. However, in the first test, we exploited an high cost and high resolution GNSS antenna that is managed by URAC Research, and the prototype that I was showing you. And what we achieved is this. We went around a little bit within the district of the Neutech Park of Bolzano, and we achieved the 80% of fixed solution over the 100% of acquisition. So the green path actually is where we have really good positioning, while the yellow one, we do have floating solutions, so not that much accurate. This is actually something that we were expecting because, of course, within the urban scenario, we do have trees, we do have also side effects and walls effects, and a lot of reflection from the signal of the satellites from the walls. So of course it was expected. But what we were a little bit astonished and also proud to reach was that when we substituted this high resolution GNSS antenna with another prototype, exactly the same one that was going around, we achieved the 90% of fixed solution. So you see now the green path is much more than before. And of course, there is a trick. It's not for free that we have been encompassing the same RTK post-processing that was done also for the first test within this other prototype. However, we demonstrated that by means of an all low-cost and open data solution, we have been able to achieve a positioning that is competing with high resolution infrastructure. Coming to the conclusion, of course, we see that this approach allows us to improve a lot the spatial data resolution in cities, and with few urban rovers, we will be able to monitor and map the urban context really easy. And of course, we do see another important feature of this application, that is bringing the data to the doorstep of citizens, so make the citizen scientists to be much more interested and active into the environmental monitoring. Of course, we see that this is still the beginning, this kind of application, so we are going to make it more powerful by means of an inertial unit and then odometer in order to be able to cope also with the floating solution, and we will embed new sensors, and of course we will put in place a pilot case, a real pilot case, maybe in exploiting the public transport. So that's all by my side. Thanks a lot, and if you do have questions, please feel free to contact me or to discuss a bit.
Thank you, Stefano. Yes, we do have questions. The first question: how do you deal with the situations like in the case where you have a big building which can cause a GPS signal issue or occlusion of signals?
That's in fact some problem that in urban scenario is unavoidable. So there are two main answers to this question. The first one is, in fact, to provide the prototype with an inertial unit and an odometer in order to, let's say, foresee a bit how this information can integrate the one that are lost from the GNSS signal. The second one would be to exploit, as they are doing in the cell phones, also the cellular network in order to triangulate with the signals, but could be also not GSM network, could also be some LoRaWAN network that nowadays allows you to do triangulation and reach the precision of level meter of accuracy.
Thank you, Stefano. We are out of time. There would still be some questions. Maybe you can see it in the comment section.
Yeah.
Thank you, Stefano. See you.
Bye-bye.
Cares about the dissemination of open hardware, and today he will tell us about different projects they are working on. Roberto, welcome.
Welcome. Thank you to have this occasion. I want to talk about the future and actual open hardware projects, in which way related to our association. I take a part of Power Progress community. Our goals are to design open hardware which is accessible to the widest range of people, to facilitate and reuse dismissed low-cost hardware using open source software, and in any way spread around open source software. And at least promote innovation in library scientific progress, to supporting different type of searching, not only related to some monopoly, but to have different and more big offers. Here some people that is in our association. I want to clarify that our association is made by hobbyists. We work for fun on this project, in our projects, in our spare time. We are not paid for that. And in our project, we have a campaign to finance, when needed, electronic engineers that help us on design the hardware projects. In any case, we have a flexible business plan, because in fact, we depend from the donations, from the collaboration. And in any case, we have selected donation campaign instead of crowdfunding, because we have the possibility to collect a donation without having the prototype before, and even we have not a fixed amount of time to realize our projects. We have selected power architecture in our projects because, for our point of view, is an innovative architecture that is mature, that is good power efficiency, even for laptop, depends on which flavor of processor you use. Is an open architecture because have an open ISA without royalties. And so for our point of view is a very interesting possibility. So starting from 1 day ago, this foundation, Open Power Foundation, have with the help of IBM make open the power ISA of power architecture processor. That means that there are no royalty to make chip compliant with this instruction set. As you can see in the draft of the EULA, there is the license that is a Creative Commons license, and there are all the typical grant to open source the hardware. As I have already said, this architecture is born in the 1990s, is starting from PowerPC. Then there was many other versions, even for embedded market in 2006. And there is every year evolution until today, until last year, that become open power ISA without royalties. There are A2 processor family that are provided by IBM as open hardware processor, are used even in BlueGen data center. And so it's possible now to make this processor run in FPGA starting from the source. And so it's possible to create a new chip starting to this design. There is even the more recent A2O design that is disclosed in May. Here there are salient features that are, even if our processor that was sell in the past, I mean in 2011, and now our open hardware processor, have in any case good quality to provide to be an engine about mobile computing. The last one have an ISA more recent. Is possible to update that. In any case, even with the version, is very capable of, as you can see in the specs that I don't go inside because it takes too much time. In any case, there is a general block diagram where you can see the internal structure that is modern, and you can see if the fabs print in the new 7 nanometer technology, as the power efficiency is very high. So is a good option even for futures version of our projects of notebook based on power architectures that nowadays have another processor with the same level of ISA, so the 207. But as our project is started some year ago, was not already possible to develop these new chips that are now open hardware, and so for the moment we use another chip, but we are open to new evolution. Now we are in the process after started the project in 2014 and started the donation campaign in 2017. Nowadays, we are near to finish the PCB design with the simulation bus. So we are in a moment very concrete. Here the specification, as you can see, the processor is an NXP with the same level of ISA of the other chip that we have already seen, 207. Have in any case good specs in relation to the processor that we use, and in any case we have, as I have told you before, we are volunteers, so we are made donation to pay the design of this PCB. In any case, was very important the good collaboration with the Slimbook that permit us to have a notebook body, because in fact we cannot imagine that this open hardware notebook can be produced in many pieces. So we have we was forced from the beginning to use an already chassis, notebook chassis body, but was not simple to find in a little number and without a motherboard. So thanks to Slimbook, was possible to find this, and so we have designed the PCB starting from this block diagram, starting from our electrical schematics that we have printed and published in our repository in 6 versions. We are arrived to make the board layout to fit in this Slimbook notebook. That is a gaming notebook that is enough big to host our motherboard. That is with a separated MXM video card, and so is a good choice. We can say that is very important to have open source that is truly CPU agnostic. That means without be connected, without be constrained to Endian. So I mean, our processor at the moment is Big Indian. Most of PowerPC software are compiled for Little Endian, but what is more important that the source must be not constrained with Endianness. Okay, we are near to, as I tell you, to pass the prototype phase. For our future plan, we are see the conclusion of the campaign and the right to prototype, and left to produce the notebook that thanks to a cube system and the Slimbook. And then we are looking to adopt for the future design the library SOC CPU GPU or the A2 power processor core from IBM. And so there are even other activity in university that we want to make thanks to the collaborators. We want to share our design and discuss with the other collaborators and the students. Okay, you can join. Now I want to clarify this new possibility in terms of shared open hardware processor. I mean, the library SOC is a 3D CPU, GPU, VPU together, together for simplify the design of the drivers, and this project is very open, is very transparent, every kind of piece of CPU, so there are not surprises like Spectre and other strange things inside. Okay. so there are no NDA, and this chip is designed thanks with LaTeX, NMegan, and OpenCore HDL that are more open than other kind of FPGA programming languages. Okay, you can see that are based on Python, this kind of FPGA languages. And in any case, there are even frameworks to convert different format of processor language to make silicon. So there are is based on OpenEYES, this processor. Have a particular type of vectorization unit for acceleration. And there is already the first outcome that is already done with FPGA. Then at the end of the year, there is a first silicon not so reduced micro printing. So 180 nanometer, but in any case, in the future, I mean, in the next years, will be more reduced production open hardware chip based on this FreeSoC processor. So, for our point of view, is a very good opportunity to have even the processor open hardware in our future design. Thank you. If you want to make some question, we have even our room that where we can continue to talk. And so I have finished.
Thank you, Roberto. We do have some questions. How difficult is it to get started with hardware, with open hardware, as somebody who's doing it as a hobby? How can one start out with it?
But I think the most important thing is to try to join people with different attitude, competence, and to try to make a network between them. And so every time you promote your project, try to involve other volunteers in any kind of capability. In any case, when you have not the competence, we can ask to the follower and to the collaborator to donate to try to pay what you cannot produce itself. In any case, with a continuous work of communication with the follower, we try every time to make a protagonist our follower.
Thank you, Roberto. Now we are out of time. Thank you for your presentation. See you.
Okay. In any case, you can follow in our room next that I think is already published our room. You can find in the virtual place. Thank you.
Thanks. Bye.
Bye.
So here returns Stefano Tondini. He's a senior researcher at the European Academy Bolzano. He'll tell us now about fiber and how it can be used for smart irrigation. Taking in consideration different factors. Stefano, you're welcome. We can't hear you. Do we have the microphone on?
Now you hear me?
Now we hear you. Perfect.
I do apologize. Okay, so yeah, I'm going to talk about a context-aware water management system for make agriculture a little bit more smart. And we are going to show you how we benefit from the Fireware platform to do that. The outline of this talk, it is going through the mainstream approaches, IoT approaches that are actually the most exploited ones in the current scenario. And we will then go a little bit to a new definition of information that we will call it context, and we will try to state how can we pass from data to information management. Then we will show you how does a context-aware system works, and we will make the comparison between the data-driven and the context-driven systems. And in the end, we will show you a live demo of the prototype we accomplished by means of Fireware to put in place a smart irrigation routine. So, when it comes to the current scenario, in fact, there are many different IoT platforms that you can exploit. Both they are public, they are private, they are open, they are vendor link, whatever. They do actually rely on a layered structure. Let me go through this really fast because I want to set up a bit of vocabulary so that we will be more easy talking about the different place where the action will be taken. However, doesn't matter if we look at horizontal or vertical, we see that usually we have the layer of the devices, the physical devices, the layer of the application, the platform, and the layer of the application where we have the interaction with the end users and where we do actually the action on the things. And doesn't matter which platform you choose, whether it is IBM, Bosch, Amazon Web Services, or whatever. Usually people, they are exploiting this platform in order to set up a data reaction principle. So they want the devices to trigger actions and following some rules that could be much more complicated or simple, doesn't matter. However, they do exploit this infrastructure in this way. However, we do believe that it's really important not to connect data and information with some arrows that they have only a single tip, but we should have every time a back and forth connection between the different information that we are exploiting when we put in place an IoT application. What I mean is that the devices data, they should interact with the user data and other heterogeneous external data, building up the context, in fact. So a bigger scenario where we can take a look at what is going on overall, not only when it comes to a specific device or a set of devices. And in this sense, this is what we call a context-aware system. So a system where, of course, we have devices and they store the data on a database, like is doing for a long time already. And we have maybe some central processing unit that is evaluating the things. And it allows us to also integrate with other external data sources. But the important thing is that the action that will be produced is not going to feed the device back or do a specific action, but is going to modify the whole context. So how the system is going on as a whole, not only on a single device. So when we look, in fact, at the difference between the data-driven usage of IoT platforms and the context-driven usage, we see the difference is this one. We are not more searching for a reaction, but we are searching for a context change. So the new information created by the devices, by the external sources, or by other third means, it will influence and modify the behavior of the devices and the system as a whole. To do that, we exploited the Fireware platform, that is actually a framework of open source components, they call it, because, of course, it's more or less sharing the same layout of the other IoT platforms. It has the layer that is the interaction with the physical system. It has a middle layer that is where, in fact, the context management of the information is done, and it has then a front-end layer that allows you to interact with the system. However, the main feature of this platform is that follows an event-driven logic. So, to be more specific, let me show you which is a way to exploit this platform in order to make it more powerful and more and getting added value reaction to the things that are happening around the context. So we move from the request response mechanism that is actually asking the things that are connected to the internet to be every time awake and waiting for triggers, we are moving from this approach to the publish-subscribe mechanism approach that, however, here we are exploiting MQTT messaging to accomplish this. However, we have a central unit that is publishing on topics, and it's providing the things that are subscribed to topics of new information only when something really crucial for the context is happening, and something that is that needs their own action is happening, so that we are lowering down a lot, not only the power demand, but also the bandwidth that is used, and so on. So let me just tell you a little bit of other two interesting features of FileWare. The first one is a simplified service path that allows you to set up the hierarchy of an application really easily by means of this structure like URI. You can just set up a really complicated scenarios of agriculture split into different topics and different location, and then reaching to the devices. Okay, and let me now go, because I want to exploit a bit of the last time for telling you how our prototype really works. Let me now show you what we encompass within this prototype that we put in place for smart irrigation. So we actually are having 4 physical things: a pump, okay, a sensor, water, soil water content sensor. We have a gateway that is collecting the signal from the devices, and we have another devices, even though we have been categorizing it through a data category. However, we have another devices that we can operate it by means of a push button, and we simulate the change into the external forecast. So these 4 things have been coupled together. Okay, we do have other components, of course. We have, for instance, the network manager that is collecting and managing the information coming from the devices. However, now here comes the sky color box of the FileWare. It would like to be a black box because it's too much complicated now to discuss in detail. However, this piece of software allows us to manage all this information in a really smart way. Let me just point out that we have a unique access point that is the context broker, and then we have a centralized unit that is deciding which information has to be delivered to each of the components of the system. And we do also can carry out some complex event processing within this. However, let me go through a more fancy image of the same prototype, that is this one. And let me also highlight the fact that is in the red zone. We do have all the piece of software that we needed to, and all the components we needed to put in place in order to make the system work. However, going back to the hardware, we have the sensor node that is sensing the soil water content within a pot. We have the gateway that is collecting through the LoRa protocol the data from the sensor, and it is connected to the LoRa server, as we saw before, the network manager that is then giving the chance the data to reach the centralized unit that is brokering all the information going around. Then we have the actuator that is coupled with a simple pump that is watering the soil whether it's too dry, and it is directly connecting via Wi-Fi to the Mosquito MQTT broker. And then, as I told you, we have this other device that by means of this push button, we just select whether the forecast are for sunny, for cloudy, or for rainy condition. All the rest, of course, we can discuss maybe in a separate room. However, components has to be set up in order to make everything work like that, like the video that I'm going to show you now, and is going to take the next minute. So you see, we have the sensor in the sun, in the soil pot, and if we remove it, we are now generating a condition that the sensor is no more seeing that we have 29% of soil water content, but you see it has dropped immediately. And what will happen if it's sunny is that the watering system is providing the water. Then we put again into the soil pot the sensor, and we reach back the same condition. But the things are not the same whether we are now changing the context. So you see, let's remove again the sensor to simulate that a drought condition, okay? Of course, we are expecting the system is providing some irrigation when the threshold is going to run. And you see now the system is irrigating. But when we modify the context and saying that it's now raining, the system is no more irrigating. It has like 10 seconds of round trip. However, you see, even though it has acquiring this 0.20% of soil water content, so really dramatic condition, the system is no more irrigating because, let's say, the overall context is saying us that it's raining, so there is no need. But now that we modified again the condition into sunny, it has been irrigating. And let's be back. So now I'm concluding with this by saying that the outreach of such an approach, they are really, really huge, because you see, beside do a more smart water management, we can perform also some predictive maintenance upon such a system, because you see, whether we trust more from a data than from another, so it's really clear that it's going to be not that much usual that we have a fake condition of sunny or rainy, because the forecast now they are running really well. We do understand that whether the soil water content is really low and it is raining, maybe our sensor is broken. So that is actually concluding the presentation. Thanks a lot for your kind attention, and if you do have questions, let's try to answer.
Thank you, Stefano. Yes, we surely have time for a question. First question, you think a private person would be able to create his own irrigation system with FireWare, or would it be way too complex?
That's really a really good question, because you see, FireWare is opening up to a really big capability, gives you a really good chance to build up some really complex systems. So they are using it for smart city platforms. So it's really a big deal. The starting up is not that difficult, because it comes everything through Docker, so you can just download the components you need, and the game is done. So not that much. However, when you want it to customize it as much as you want, then it comes a big work to be done, and my developers, they do that.
So you think it's an affordable thing? Is this also, could this also be used in places where there's scarcity of water?
That's, of course, that's actually using remote sensing data, for instance, coupled with in situ data, that having in situ data, even though we are going for low-cost solution, it's really expensive sometimes, and there are a lot of bottlenecks to distribute and to deploy in situ sensors. So having it like coupled with some remote sensing, it would be way better in order to accomplish for the most smart water management.
Thank you, Stefano. I think these are all the questions we have Thank you for being here for a nice presentation. We'll see you.
Okay, thanks a lot.
Bye.
Bye-bye.
Thank you for attending SFScon. For today we are finished. We'll see you tomorrow.